Derivatives of sine and cosine functions. Okay, so we are going to first look at this derivative rule. Again, this notation is saying the derivative, D stands for the derivative of the function sine of x with respect to x. That's going to be equal to cosine x. Also, we're going to look at the derivative of cosine x with respect to x. That's going to be equal to negative sine x. So we're going to go through the proof of this derivative, and the derivative of cosine of x would be very similar to the other one. This would be a proof that you could definitely expect to see on the next test, so make sure that this makes sense to you. Okay, this proof, we are going to use the Squeeze Theorem. So we went through this proof. It states, so the limit of sine delta x all over delta x as delta x goes to 0 equals 1. That's the same thing as the limit of sine of x over x as x goes to 0 equals 1. Okay, this right here, we can make it any variable we want. Okay, so for the proof, again, we're trying to prove that the derivative of sine of x is equal to cosine of x. So for this proof, we are going to let f of x equal sine of x, and then therefore f of x plus delta x would equal sine of x plus delta x. We're going to use the definition of the derivative, which is f prime of x equals the limit of f of x plus delta x minus f of x all over delta x as delta x goes to 0. Not any time, but the majority of time that we are proving one of the derivative rules, it's going to start with the definition of the derivative. Okay? So let's go through this. So step 1. So notice we're just going to substitute. So f of x plus delta x, that's going to become sine of x plus delta x. Okay? We're just going to substitute that into the definition of the derivative. And f of x is going to become sine of x. Okay? So there's step 1. Okay? Notice, this should be a trig identity that you are very familiar with. Notice that if you have sine of a plus b, so the sum identity for sine, that's going to equal sine of a cosine of b plus cosine of a plus cosine of b. You could think of this as sine of x, where x is the same thing as a, and delta x is the same thing as b. So then we have sine of x cosine of delta x plus cosine of x sine of delta x. Okay, so then I am going to substitute this part here in right there. That's going to become this part, using that identity. So I've done that here. Hopefully you see that. And that's going to be step number 2. Step number 3, we're going to rearrange this function here. Okay, so I've got sine x cosine x, and then I'm going to move negative sine x over here, and then I'm going to put cosine x sine delta x over there, and I'm going to separate this, okay, with an addition sign, and then both of these are going to be divided by delta x. So that's going to be step 3. Step 4, out of this function here, I can factor out sine of x. So I'm going to factor out sine of x in front of the whole limit. And the reason why I can factor that out in front of the whole limit is delta x is going to 0. So delta x will not affect sine of x. So no matter what, that's just going to stay sine of x. So then I have this cosine delta x minus 1 all over delta x. Here, same thing. I'm going to factor out cosine of x. And I'm just going to distribute the limit over here as well. So I'm going to factor out cosine of x, and I'm still going to take the limit of delta x, or I'm sorry, the limit of sine delta x all over delta x as delta x goes to 0. Okay? Then let's look at this part here. Okay? Cosine delta x minus 1 all over delta x. So cosine delta x minus 1 all over delta x, I'm going to multiply that by the conjugate. And when I multiply that by the conjugate, I'm going to end up getting cosine squared delta x minus 1 all over delta x times cosine delta x plus 1. Okay? And notice, since sine x squared, sine squared delta x plus cosine squared delta x equals 1, that's the Pythagorean theorem, I can adjust this where I could subtract sine x delta x to the other side and then subtract 1. I could move this around and get cosine squared delta x minus 1 equals sine squared delta x. And then I can substitute that here. So now I have negative sine squared delta x all over delta x times cosine delta x plus 1. And then I'm going to break apart this negative sine squared delta x as sine delta x times negative sine delta x. Okay? All over delta x and cosine delta x plus 1. So I'm going to take that, okay? This is going to go right here. Okay? And now I can evaluate the limit. Okay? So notice this limit here, this is the squeeze theorem. So I still have sine of x out in front. This limit here, that goes to 1. Okay? I can evaluate this limit here when this would be negative sine when I do direct substitution. If this was 0, we know negative sine of 0, that would be 0. We know cosine of 0 would be 1. 1 plus 1 would be 2. 0 divided by 2, that's still going to be 0. So that's all taken care of. And then cosine of x. So how I got cosine of x, I evaluated this limit. Okay? So this is the squeeze theorem again. The limit of sine delta x all over delta x as delta x goes to 0, that all goes to 1. 1 times cosine of x is cosine of x. So now you have sine of x times 1 times 0 plus cosine of x. That's going to result to cosine of x. This is the proof. This is showing me that the derivative of f of x equals cosine of x. And remember, f of x to start with was sine of x. Hopefully that proof makes sense. That is something that I would expect that you could reproduce if I asked you to prove that on a test. Alright, so let's just go through a few of these applying the rule. So part A, y equals 2 times sine of x. They want you to find the derivative of that. So that'll be y prime equals 2 cosine x, because the derivative of sine of x is cosine of x. We just want you to prove that. Next, part B, y equals sine of x over 2, or 1/2, times sine of x. If we want to take the derivative of that, it's going to be 1/2. The derivative of sine of x would be cosine of x. Look at C. Y equals x plus cosine of x. So the derivative of this equation, the derivative of x is 1. The derivative of cosine of x is negative sine of x. So we didn't go through the proof of that, but we stated the rule up there. That would be that answer. Okay. The last one here, if we took the derivative of this function here, the derivative of cosine of x would be negative sine of x, and the derivative of negative pi thirds sine of x would be negative pi thirds cosine